Hello class, you are welcome back. Today we want to continue on the dealings with our topic, continuity of a function. Continuity of a function. You'll recall the last time we discussed about the limit theory and then we moved on to dealing with continuity of a function. We're able to find that limit is part of the steps we take in dealing with continuity or in verifying whether a function f of x is continuous or not in x. So we continue this morning with this. As you recall, if you remember, we said there are three steps to prove that function f of x is continuous in x. One is f of a is defined. Two, we also said that limit of f of x as x approaches a also exists. And that's in two fashions, from the left side and from the right side. The limit of f of x from the right side must equal the limit of f of x from the left side for the function to be continuous. And also, we also said for the third step is that the limit of f of x as it approaches a must equal to f of a. That is step 1 equals step 2. That gives us step 3. So in other case, you can just say f of limit as f of x approaches a equals f of a equals limit of f of x as x approaches a from the left side also equaling as x approaches from the right side. That is what we are discussing, and I have a lot of examples which I will just allow you to go through while we move on as fast as we can. See an example here. You have to show that f of x is continuous or otherwise at x equals 2 and at x equals 3. This is the function, because the function f of x is in three versions, let's say three variants. F of x is x root of x plus 2, condition as x less than 2, x squared minus 2 condition between x between 2 and 3, and then 2x plus 5. The condition is that x is greater than or equal to 3. The solution is here. You can see the step 1, f of 2 like that. You see how we are using the function. They're using second function since x is greater than or equal to 2. F of 2, that means x is equal to 2. That is what we are going to use the second function, that is x is greater than or equal to that. X, the only way where x is equal to 2 is the second function. That's why we're using the second function here. For the step 2, limit as f of x approaches, as f of x approaches 2 from the left side, that is x approaches 2 raised to the power minus, so the f of x, that is the root of x plus 2. Using the first function, since x is less than 2, from the left side is less than 2. Also, from the right side is greater than, that would be also for the second function as well. And looking at that, you can see that the 2, 2, 2, that means step 1 is equal to 2, step 2 goes to 2, step 3 also, we get limit of f of x as x approaches 1, x approaches 2 rather, is equal to f of x, that's f of 2, which is equal to 2. That means f of x is continuous at x equals 2. Since the f of a exists and the limit as f of x approaches 2, from that the right side and left side is also equal to 2. That means there is continuity at x equals 2. What of at x equals 3? It's a different ball game here. You can see, using the same way we are doing for x equal to 2, we have limit of as x approaches 3 does not exist, because you can see in step 2, limit as f of x approaches from left side of 3. You can see what how we just make sure you study how we actually use the particular functions we use from the f of x representation. So you can see from the left side equals 7, from the right side equals 11. You can see that limit of f of x as x approaches 3 from the left side and 3 from the right side, they are not the same. This gives us that the limit as f of x is not equal to limit as x approaches, as x approaches 3 from the left side, is not equal to limit of f of x as x approaches from the right side. That means the limit as x approaches 3 does not exist. That's what it means, does not exist. Does not exist. So f of x is discontinuous at x equals to 3. And this type of discontinuity is what we call jump discontinuity. Jump discontinuity, as I said in class, is jump discontinuity when this particular condition holds. Then that type of discontinuity is jump discontinuity. When limit of f of x as x approaches from negative side is not equal to limit of f of x as x approaches from the positive side. That's where we have jump discontinuity. Look at example 2. You have to show whether f of x is continuous or discontinuous at x equals to minus 1. Using the same approach that we used for our first example, you can say you don't want to use the first function, you don't use the second function. You can say f of 1 here, f of minus 1, we are dealing with minus 1. So x of minus 1 is here. We are using this. We are using x of minus 1. This is what we are using here. So that's why we have f of minus 1 equals to 5. Then limit as x approaches minus 1 from the left side of it to be less than minus 1. That's why we're using the very first function here, the very first function. And when limit of f of x approaches x from the approaches minus 1 from the positive side, it gives us 3. You can see limit of the f of x from the right side is equal to the f of x, limit of x on the right side. They are equal, but it's not equal to the f1, f of minus 1 here. It's not equal to this. As you can see, step 3, limit of f of x as x approaches minus 1 is not equal to f of x. That is f of a here. That means there is discontinuity. There's discontinuity, and this kind of discontinuity is called hole. This is a condition here when the limit of f of x as x approaches negative side from negative side is equal to limit of x as x approaches from the positive side and is not equal to f of a. That's where we have hole as a form of discontinuity. You can see the difference between when discontinuity is called the hole and when the discontinuity is called a jump. Just take note of that, the two types of discontinuity that I've mentioned so far. Let's look at example 3. F of x equals x squared plus 1 when x is greater than or equal to 3, 2, and then f of x equals 7 minus x when x is less than 2. It's asking, is f of x continuous at x equal to 2 or not? The same way, step 1, you can see f of 2 equals 2 squared plus 1 using the very first, because this is the one that contains that x is equal to 2, right? That's why we're using the first function at this point. Step 2, limit of f of x as x approaches 2 from the negative side. It gives us 7 minus, please, we are using the second function because it's less than 2. 2 negative side is less than 2, and limit of f of x as x approaches 2 from the positive side. We also use the first function. This is where x is greater than 2. You can see that step 1 equals to step 2. Therefore, limit of f of x as x approaches 2 exists and is equal to f of 2. That gives us that the f of x is continuous at x equals to 2. Now, example 4. Look at this. Now, this is a very interesting example. For the previous examples, we have been asked to confirm or verify whether the function f of x is continuous or discontinuous. But in this example, we have been told that the function is continuous. We are told that the function is continuous. We have to get the values of a and b that make the function continuous. Look at that, f of x equals as squared plus bx, where x is less than minus 2, minus 7x when x equals to minus 2, and ax cubed minus 10b when x is greater than minus 2. Find a and b if f of x is continuous at x equals minus 2. Or, in other words, we can ask that find a and b, it is continuous everywhere. That what you are doing continuous everywhere, they are continuous from minus infinity to positive infinity. But the issue here is at x equals minus 2, there's like going to be a jump, a hole there. Because coming from the positive side, coming from negative side, you see, there's going to be kind of a jump at x equals minus 2. That means that's an issue at x equals minus 2. That's why we are going to find a and b if x continues at x equals minus 2. It may be given that, it may be given is continuous everywhere. The condition, the limits on the right hand side, this limit we always help you. We always help you to know at which point you have to find the discontinuity. Now, for its continuity, another way of writing continuity is the condition is this: limit of f of x as x approaches minus 2 from the left side equals limit of f of x as x approaches 2 from the right side equals f of minus 2. You remember? F of minus 2. Just take note. Firstly, as you start, f of minus 2 equals minus 7, that's minus 2, because this is x of minus 2, where x equals minus 2. That gives us 14. Now, limit of f of x as it approaches minus 2 from the left side equals 14. You can see it will equal to 14. It is equal to 14 as you can see, like just the what do you call it? The condition I just gave now is equal to our f minus 2 is 14. So the limit from the right side and the limit from the left side will always be 14. That's why we have this a squared plus b equals to 14 and equals minus 4a. That just to simplify this, using x to be minus 2. Let it be equation 1. Then coming again for x of minus limit of f of x as x approaches 2 from the positive minus 2 on the positive side gives us this. So it's always equal to 14 from that. That is the overriding consideration you look when you are writing the conditions for continuity or discontinuity. Now, solving 1 plus 2 gives us this. Simplifying gives us b to minus 3, and then we are going to b, and then from 1 we can get our a. Using substitution, we go with minus 3 and our a to be 2. That is for we have found a and b as we are required to find. Let's say another simple example, example 5. Find the values of a and b that make f of x continuous everywhere. Look at the conditions we are given: x equals to 2, x less than 2, x between 2 and 3, and x greater than 3. That means we are going to find one of discontinuity at x equals to 2. At x equals to 2, that is everywhere. Now look at the function we are given: x squared minus 4 over x minus 2, ax squared minus bx plus 3, 2x minus a plus b. 2x minus a plus b. All right. So you can see the solution. F of 2 is straightforward. You know what that would be using the second function here to get this. And then you can see we're putting our 2, give us 4a minus 2b plus 3. That gives us equation 1. The limit of f of x as x approaches minus 2 from the left side. From the left side, when I say negative side, okay, I also mean from the left side. Because limit as x approaches to the left side of x squared minus 4 over x minus 2. You can see because that one x is less than 2, we are using the very first function. That's equation 2. And the limit of f of x as x approaches 2 from the right side gives us, from the right side, that is x is greater than 2. That's the second function we are making use of at that point. Now, recall for continuity. This is the rule for continuity again. Recall it. Just take note. Always recall this. This is the rule for continuity. Look at that. So limit as equals this. This should be equal here. Equal sign. Limit as f of 2. Limit of f of 2 equals f of 2. So equating 1 and 2 that we did before gives us this, and then equals this. You can see if you have to put 2 here, it will not give us what you want to give us. If you put 2 here, 4 minus 4 is 0, then 2 minus 2 0. So you need to factorize because this is can I say product of sum of squares. Yes. Now you now factorize it. We have this. From here, we can have, it leads us to x minus 2 cancelling out to 4a minus 2b plus 3. That gives us, that then gives us the next one. It leaves us with x plus 2 limit as x plus 2 approaches 2 on the left side, gives us 4a. Now from there, we got our, now we got our minus 1 minus 4a minus 2, 1 equals 4a minus 2b. Let that one be equation star. Now, because this, we have a and b, we cannot get two unknowns from one equation. Then we need two equations in two unknowns to get a and b. So we find if f is continuous at x equals 3. You get the first one, x equals 2. Since they are dealing, the continuity we are given is between 2 and 3. So when we got an equation, when we use x equals to 2, we got a linear equation in two unknowns. We now need to get the other limit of 3, x equals 3, to get the other linear equation so as to get a and b. The limit of f approaches 3 from left side. All right, because f the limit of x now this we know x is of that out to give us this. Just this ordinary mathematics we are trying to do here. Once you know the limit of f of x as x approaches left side, right? It's the same thing. That's the shape. Now, what we be on the right side here, we also be on the left side. So you see what I'm talking about. Now, note that limit will not be useful here. Limit as approaches plus will not, since f of x will be the same as f of 3. As f of 3. So we are going to be, so be useful. What will be useful be just the, what will be useful will just be f of as limit as f of x as x approaches 3 from the star and star simultaneously. We have a to be half and then b to be half. A to be half and b also to be half. That's how to solve that. We are given, we are asked to find a and b that make a particular function to be continuous. All right. Example 6. Look at this example 6 as well. Also something like that. Find a and b that make the piecewise function of x continuous everywhere. Continuous everywhere. Now we are going to deal with f of x minus 1 is between minus 1 and 1. F of minus 1 because this, the f of limit of f of x as x approaches minus 1 from the left side gives us limit of 2x plus 1. Yeah, because it's the first side. X from the left side, meaning is less than minus 1. That's what it means, less than minus 1. Limit of this equals to minus 3. By the time you put minus 1 into this, you get minus 3. Limit of f of x as x approaches minus 1 from the positive side, from the right side, gives us from the right side that's greater than minus 1. We are going to use the second function. That's what we have there. Now, the limit as x approaches, because I said that now equating this limit of our x approaches minus 1 from the left side equals f of x. So that gives us a minus equals to minus 3, gives us that. To get the other equation, check until that x equals to 1. You remember the last time we did 2 and 3, this one between minus 1 and 1. So f of 1 equals a plus b, and then limit as f of x, limit of f of x as x approaches 1 from the left side equals a plus b. Limit of f of x as x approaches 1 on the right side. Now, limit of approaches 1 from the right side is useful. The other one, because the right side will be equal to the left side. That's why it's not useful. Now it is useful here. That's why we have this a plus b equals to 7. And then one star plus star, because then b equals to 2. And substituting, we have a to be equal to 5. We have a to be equal to 5. That is what we are talking about when we are asked to find. These are the interesting examples I wanted to actually show you, where we are asked to find a and b, two values that make a particular function. Instead of giving us a function and finding if it's continuous or discontinuous, we can be given a continuous function and then give us some variables within that particular function that we are going to find. The variables that make the function continuous A and B, you have to find it. That is the purpose of these last three examples. Please study it well, and I hope you understand. So if there's any question regarding this, I think I'm free to be consulted. You may contact me, but try as much as possible to get this. Work your hand on it yourself, not just to watch, and verify all the answers I got so that you have a proper grasp of the issue of limit and continuity. And by the way, you may work your hand on this practice exercise. Find the values of A and B that make the piecewise function f of x continuous everywhere. Because you can see it range between 1 and 2. So you start, find a continuity at x equals to 1, at x equals to 2 to get the other linear equation. From where you now do substitution to get your values for A and for B. That is clearer. So this I'm going to stop at the convenient point now, and I hope you understood the lesson. If there's another area that is still proving stubborn, you may meet me possibly in class, or you meet physically in class, or can also meet me via this medium, this YouTube channel. You can ask your questions there. I will gladly answer you. Have a wonderful day. Thank you. Bye for now.